farms across the globe find themselves in a difficult position. For generations, the story of agriculture was one of increasing abundance, driven by powerful tools like chemical fertilizers. These nitrogen-rich compounds fueled the Green Revolution, allowing us to feed a rapidly growing human population. But that story is changing. In many of the world's most productive breadbaskets, the land is reaching a point of saturation. Adding more fertilizer no longer guarantees a bigger harvest. Instead, crop yields have begun to plateau, refusing to climb higher no matter how much more we apply. This creates a challenging economic reality for the people who grow our food. The cost of farming inputs, particularly nitrogen fertilizer, has soared dramatically in recent years. This is due to volatile energy prices and complex global supply chains. They must spend more and more to maintain production, while the returns for their crops often fail to keep pace. This economic pressure threatens the viability of family farms and the stability of our food systems. It is a clear signal the old ways may not be enough. A new approach is urgently needed. Beyond the farm gate, heavy reliance on synthetic fertilizers has created a cascade of environmental consequences. When these chemicals are applied in excess, they do not simply disappear. Rain washes them from the fields into our rivers, lakes, oceans. This nutrient runoff fuels massive algal blooms which starve the water of oxygen, creating vast dead zones where aquatic life cannot survive. The production of nitrogen fertilizer is also an energy-intensive process, releasing significant amounts of greenhouse gases and contributing to a warming climate. The very tool that helped us grow is now harming the delicate balance of the ecosystems we all depend on. The search for a new path forward has become a critical mission. Growers need tools that enhance crops without crippling debt or environmental harm. They need methods that work with nature, not against it. The solution will not be a single magic bullet, but a suite of innovative ideas. Imagine a way to boost a crop's potential before the seed is even planted. This is the core idea behind a new and promising approach known as resonance farming, or sometimes called quantum growth. It steps away from fertilizer chemistry and dives into the physics of life. At its heart, resonance farming is simple. It uses carefully controlled, low-strength magnetic fields to talk to seeds, to talk to plants. The goal is not to change genes, but to gently tune internal processes, like tuning a musical instrument for a clearer, stronger note. Living things are partly electrical systems. Subtle bioelectric signals course through plants, directing their growth, their response to stress, their use of nutrients. Resonance farming enhances that communication. We expose seeds, or the water used for irrigation, to specific electromagnetic patterns to influence those signals. This process, when applied to seeds, is called magnetopriming. It prepares a plant for a more vigorous life and helps unlock its inherent potential from the start. This is not genetic modification. No foreign DNA is introduced. What changes is efficiency. The treatment acts like a coach, giving the seed instructions on using its stored energy more effectively, absorbing water more quickly, mobilizing internal resources, and germinating with greater speed and uniformity. To understand how a magnetic field can influence a living plant, we must look deep inside its cells. Plants are not static, passive things. They are dynamic systems, constantly buzzing with activity. Their life depends on the movement of tiny charged particles called ions, calcium, potassium, magnesium, ions flowing through channels in the cell membrane. This flow is not random, it is a highly controlled form of communication. The movement of these ions creates tiny electrical currents, signals. Those signals tell the plant to grow, to defend itself against a pest, or to search for water. Pulsed electromagnetic fields, or PEMF, provide a way to interact with this hidden language. Extremely weak, often no stronger than the Earth's natural magnetic field. Gentle pulses at specific frequencies influence ion channel behavior, like a key fitting into a lock. The right frequency encourages channels to open more readily. That lets signaling ions, especially calcium, flow into the cell. Calcium influx acts as a powerful trigger, a master switch, activating a cascade of biochemical reactions. One key result: production of nitric oxide. Nitric oxide helps regulate growth, development, and responses to environmental stress. Increased calcium also stimulates mitochondria, the cell's powerhouses. Mitochondria produce more ATP, more energy for the seed. More energy fuels awakening and early growth. The process enhances the plant's own natural systems. The magnetic field does not force anything unnatural. It provides a subtle nudge, fine-tuning internal machinery. Optimizing metabolism before facing the outside world means seeds can germinate quickly, establish strong roots, and thrive in complex soil. This is the elegant science behind tuning a seed. The process of treating seeds with a magnetic field before planting is known as magnetopriming. It is a simple, dry, and clean procedure. Simple, dry, clean. Seeds are placed within a specialized device and exposed to a steady or pulsing low-strength magnetic field for a set period, which can range from a few minutes to an hour. This treatment fundamentally changes the way the seed interacts with its most essential resource: water. Within every seed, water molecules are arranged in clusters. The magnetic field can influence these clusters, altering their structure and making them more organized and biologically available for the seed to use. This change in water structure has a profound effect on the first stage of a seed's life. A magnetoprimed seed can absorb water from the surrounding soil much more quickly and efficiently. Faster water uptake, or imbibition, is the primary trigger that awakens a seed from its dormant state. It kickstarts the metabolic processes that lead to germination. By accelerating this critical first step, magnetopriming can significantly reduce the time it takes for a seed to sprout. The seed is not genetically different, but its internal mechanics have been primed for rapid activation, giving it a crucial head start in the race for life. Faster germination is only the beginning. When an entire field is primed, emergence is more uniform, creating an even, dense canopy more quickly, outcompeting weeds for sunlight, water, and nutrients, potentially reducing the need for chemical herbicides. It also simplifies management practices like irrigation and harvesting, as the entire crop is at a similar stage of development. This early life advantage translates into a more robust and resilient plant. The effectiveness of resonance farming is not just a matter of applying any random magnetic field, The specific frequency and strength of the field are critically important. One of the key scientific principles that may explain why certain frequencies are so effective is called ion cyclotron resonance, or ICR. This concept originates from physics and describes how a charged particle, like an ion, will move in a circular or spiral path when in the presence of a steady magnetic field. The speed at which it circles is its cyclotron frequency, specific to the type of ion and the strength of the magnetic field. Our planet Earth is a giant magnet, generating a geomagnetic field that all life has evolved within. The ions inside plant cells are therefore already influenced by this natural field. The ICR theory suggests that if we apply a very weak, pulsing magnetic field at a frequency that precisely matches the natural cyclotron frequency of a specific ion, such as calcium, potassium, in the Earth's field, we can create a resonance effect. Imagine an ion spiraling in a magnetic field with an incoming wave matching its frequency, causing the spiral to widen. In a plant cell, when an applied pulse matches the ICR frequency of calcium, it can enhance passage through specific channels. Even a very weak signal, when tuned correctly, can have a disproportionately large biological effect. It does not need to be a powerful force. It just needs to be the right, tune. Whispering in a language cells are naturally attuned to hear. By tuning technology to the Earth's magnetic field and the natural resonant frequencies of essential biological ions. We work in concert with physics and biology, an elegant harmony between technology and nature. The claims of resonance farming are not merely theoretical. They are supported by a growing body of evidence from laboratories and real-world farm trials around the world. In controlled lab settings, the initial benefits are clear and measurable. Numerous studies have documented that magnetoprimed seeds germinate significantly faster than their untreated counterparts. In some experiments with crops like wheat and maize, the time to emergence has been reduced by 30% or even more. This is a critical advantage. Every day before sprouting is a day vulnerable to disease and pests. Scientists have observed remarkable changes in root development. Treated plants frequently develop longer primary roots and more extensive networks of secondary roots. A deeper, more complex root system anchors the plant more firmly and explores more soil for water and essential nutrients. That enhanced architecture also fosters stronger relationships with beneficial soil microbes, especially mycorrhizal fungi that extend the root system, bringing back phosphorus and water in exchange for sugars from the plant. Most importantly, these lab advantages are translating into tangible gains in the field. In maize trials in the American Midwest, treated seeds have shown average yield increases of 10 to 15%, with some reaching as high as 25% in optimal conditions. In Brazil, treated soybeans have shown greater resilience in drought, keeping yields higher than nearby untreated fields. Similar double-digit increases have been reported in wheat, rice, and other staple crops across diverse climates and soils. Often, these gains come without any increase in fertilizer. Some trials even show farmers reducing nitrogen use by 10 to 15%, while still raising yields with treated seeds. Healthier plants with superior roots are better at finding and using nutrients already in the soil. The evidence suggests resonance farming is not a lab curiosity. It is a practical tool for measurable crop and profit gains. The potential benefits of resonance farming extend far beyond just increasing crop yields. This technology offers a pathway to a more sustainable and economically sound form of agriculture. One of its most significant environmental advantages is its completely chemical-free nature. The process uses only physical fields and leaves absolutely no synthetic residue in the seeds, the soil, or the water. This stands in stark contrast to conventional seed treatments that often involve chemical fungicides or insecticides. By eliminating these chemicals, resonance farming helps to protect the delicate web of life in the soil, including beneficial insects, earthworms, and essential microbes. This approach can also play a vital role in reducing reliance on synthetic fertilizers. As treated plants develop more extensive and efficient root systems, they become more adept at sourcing their own nutrition. They can better access existing nutrients in the soil and form more productive partnerships with nitrogen-fixing bacteria and mycorrhizal fungi. This increased nutrient use efficiency means farmers can get the same or better yields while applying less fertilizer, reducing nutrient runoff into waterways and the carbon footprint of fertilizer production. From an economic perspective, the advantages are compelling. There is an initial investment in the treatment technology, but the potential return is substantial. Reduced spending on fertilizers and herbicides lowers costs and improves margins. Higher, more stable yields mean more income. For smallholder farmers, low-cost, portable, solar-powered treatment units could be a game changer, letting them leapfrog heavy chemical dependency and become more resilient and self-sufficient. The business models are designed to be accessible. Hardware as a service, seed processors offering primed seed, or on-farm leased units with seasonal or per-bushel pricing, lowering the barrier to entry for both large operations and small family farms. As with any new technology that interacts with living systems, it is natural and necessary for questions about safety and risk to be raised. The public is rightly concerned about the potential impacts of electromagnetic fields on health and the environment. It is crucial to note that the fields used in resonance farming are fundamentally different from those associated with high-power lines or cell phone towers. The PEMF signals are of extremely low frequency and low strength, often designed to mimic the Earth's natural magnetic field, and akin to fields generated by common household appliances. To date, research into these specific low-frequency, low-strength applications has not revealed evidence of harm to humans, animals, or beneficial insects like pollinators. However, building public trust demands transparency, rigorous independent testing, and the publication of peer-reviewed safety data, plus long-term monitoring for unintended consequences. Openly addressing concerns about biohacking and side effects with clear, accessible science will be paramount for acceptance. The path to market will also be shaped by regulators. In the EU, the precautionary principle can mean extensive reviews and gray areas for physical inputs like EMF. In the US and some regions, focus on the end product can enable faster approvals if safety and substantial equivalence are shown. To navigate globally, companies must engage regulators early and often with robust safety and efficacy data, so science-based decisions protect consumers and the environment. Done right, this builds the social license to operate and the foundation for responsible adoption. The journey of bringing resonance farming from a promising concept to a standard agricultural tool requires a clear and deliberate strategy. This is not a magic solution that can be deployed overnight, but a powerful new instrument that must be carefully calibrated and integrated. The path forward can be envisioned as a three-step roadmap: pilot, service, integration, prioritizing verification, accessibility, and synergy. First, pilot and verify through extensive multi-year field trials in varied conditions, different climates, different soil types, corn, wheat, soy, rice, with treated seeds grown beside untreated controls under identical conditions. Collect meticulous data on yield, plant vigor, root development, nutrient uptake, soil health, and water usage. Robust, independently verified data is the bedrock of trust and adoption. Second, establish flexible hardware as a service. Seed companies and co-ops offer magnetopriming at processing facilities. On-farm, lease portable devices with seasonal fees or per-ton pricing, lowering upfront costs and accelerating adoption. Third, integrate with precision agriculture. Sensors and drone imagery flag drought-stressed zones. Apply targeted water pulsed with specific magnetic frequencies. Fuse PEMF with analytics and AI to deliver exactly what plants need, when and where they need it. This flexible, data-driven approach lowers barriers and maximizes impact for both large operations and smallholder farms. A shift from conquering nature to collaborating with it, a vital step toward a truly sustainable future for farming and our planet.